Congratulations, guys. You have made it to the last algorithm we are learning in this course, merge sort. So merge sort is, to be honest, quite a bit more difficult than the previous two we've learned because merge sort involves recursion. However, if you can make it through merge sort is significantly more efficient than the previous two, bubble sort and insertion sort, which we're actually going to examine in our algorithm speed tutorial, our last course. But before I get ahead of myself, let's just kind of dive into merge sort. So as I said, merge sort is recursive. So how it works is it divides the large data set, so the whole set, the whole array you might think of it, into smaller sets or smaller arrays. And it continuously divides these sets until the sets are actually only contain one element. And if you think about it, these one element sets are technically sorted. I mean, there's only one element, so it has to be in sorted order because there's only one. So of course they are. So now you have these multiple sets. So let's just kind of, for an example, say we have our largest array, our main data set has 4 elements. So now we have 4 sorted individual sets. We have our 4 individual elements, and we begin to merge these sets. So we're going to take the first 2 elements, these first 2 divided sets, and we're going to compare the smallest elements in the set. Well, since these sets only have one element, we only have one choice in each sorted set. So we compare these two, and the smaller element becomes the first element in the sorted set, and the larger element becomes the second element in the sorted set. So now we merge these sets of one element into one big sorted set of 2 elements. And now we do this with the other set as well. The third and the fourth elements in this 4 elements elements and then those 2 become one sorted set as well. So now we're left with 2 sets of 2 element sorted sets. I hope the use of the word set isn't confusing you. This just means array. And so these sorted sets will progressively become larger. And so then what we do is we'd compare these 2 sorted sets by comparing the first 2 elements of each of these arrays. So the first element is, of course, the smallest one of each array. And so we kind of build the set in that way as well. And then after that, we will have our completely sorted data set. It will be completely merged back into 4 elements. So hopefully that wasn't too confusing. But in case it was, don't worry. This visualization will clear things up, I promise. So let's first recursively divide this set. So we're going to divide this set of 8 into first 2 sets of 4. And then we're going to divide that into 4 sets of 2. So we're just dividing each set in half. And then after that, we divide each set into a set of just one element. And now each of these different colored sets are actually sorted because, like, say, take a look at the green one with 6. 6 is sorted because 6 is the only one in there. So we can call that sorted. So now we're going to start to merge these sets together. So what we're going to do is compare the first 2 sets. We have 6 and 3. 3 is smaller than 6, so 3 becomes the first element of this set, and 6 is the next element. Now these are one sorted set. We're going to do the same with 2 and 7. So 2 is the smaller element, so 2 becomes the first element of the next set. 7 is the other one. Now these are sorted as well. We're going to compare 4 and 5. 4 is smaller. 4 is the first element. We're just left with 5. 5 fills in the last spot. Now on to our last 2 element set. 1 is smaller than 8. 1 is the first spot in our next sorted set. 8 fills in the last spot. So now we have 4 sorted sets completely. So we're kind of making progress here. So now this is sort of where you kind of see what merge sort actually is. So now we're going to compare the first 2 sets again. But you'll see that now these aren't just one element sets. These sets have 2 elements. But we start with this first elements because we know these are the smallest. So we know that if the smallest element either has to be 3 or 2 because it's the first element of these already previously sorted sets. In this case, 2 is smaller, so 2 becomes the first element of this next set. Now what do we compare 3 to? We compare it to 7. We can still compare it to the other set because we already know 3 is smaller than 6. We already did that comparison, and that's the beauty of this algorithm. We kind of try to avoid as many repetitions as possible. So we compare 3 to 7. 3 is obviously smaller than 7. So 3 is the next element of this sorted set. Now we compare 6 to 7. 6 is smaller than 7, so 6 is the next element, and then 7 fills in the last spot. It's the last element left. So now we have another set completely sorted. This one has 4 elements now. So now we do this with the last 2 sets as well, the last 2 sets of 2. So we compare 4 to 1, the first 2 elements of each set. 1 is smaller than 4. So 1 becomes the first element of this next array. Now we compare 4 to, can you guess it? 8. We compare 4 to 8 because that's a comparison we haven't done yet. It's in the other set. 4 is smaller than 8, so 4 is the next element. 5 is smaller than 8 as well. That's the next comparison. So 5 is the next element, and then 8 is the only one left. That fills in the last spot. And now we have another set that is completely sorted of 4 elements. And so now the final merge is going to take place. We have 2 sets of 4, so we're going to compare the first 2 elements. 1 and 2. 1, of course, is smaller. So 1 is going to be the first element. Now we're going to compare the first 2 elements again, but of course 1 is gone. So now the first element of this red set is 4. So 2 and 4, 2 is smaller. That's going to take that spot. 3 and 4, 3 is smaller. I think you're probably starting to get the idea. 6 and 4, 4 is smaller. So 4 fills in this spot here. 6 and 5, 5 is smaller. So now 5 takes this spot. 6 and 8, 6 is smaller. That takes that spot. And now 7 and 8. 7 is smaller, takes the next spot. 8's the only element left. That slides in there. Boom. We have our completely sorted set using merge sort. So the thing that you really need to understand is that I know that seemed a lot more complicated than insertion sort and bubble sort in terms of probably comprehending. And you're right, it is a little more difficult to understand. But when you have massive, massive data sets, if you kind of reflect back on bubble sort, swapping that many elements that many times is quite inefficient. But with merge sort, we're merging these sets into smaller and smaller sets, and we're avoiding repeating comparisons. And so what we're doing is actually a lot more efficient in the long run. Let's see this in action with some Java code.